Hello. Oh, here's another example of integration by parts using this problem. So we have x squared sine of 3x dx. Okay. So our first step is to let some value of u and then get its derivative and then determine the dv and get its integral. Okay. So say let's assign our x squared here as our u, and then the remaining part here is our dv. So we have sine 3x dx. Okay. So as you can see, the derivative of this is just 2x dx. Then the integral of this is the integral of sine is negative cosine 3x. Then the derivative of 3x is dx, so we need to divide it by 3. So we have negative cosine 3x all over 3. And then when we have this, we can now apply the integration by parts, which is, let me rewrite our original integrand. So we have, it is equal to u v minus the integral of v du. Okay, let's simplify this. So we have negative 1/3 x squared cosine of 3x, then minus, and then negative times negative, so we have positive, and then we have 2 over 3, then the integral of we have x, then cosine 3x dx. Right? So as you can see here, it gave us a little bit more simpler dv du, I mean, versus our original integrand. Okay, so maybe we can try to integrate this one more. So what will be the integral of the x cosine of 3x d of x? Okay, so as you can see here, this we don't have a direct formula regarding this form, so maybe we can apply again the integration by parts, solving this part. So solving this part, we have to let u is equal, say we have x, then our dv is the cosine 3x d of x. Okay, so getting the derivative of u, du, and the derivative of x, just dx. Then for b, the integral is v, then the integral of this. So the integral of cosine is just positive sine 3 of x, and then the derivative of 3x, just 3. So we need to divide this whole term by 3. Okay, so we have 3 sine 3x all over g. Okay, and from here we can now apply the form based on our integration by parts. So this term here is equal to the integral of this term here is equal to u v. So we have u, then our v is sine 3x over 3 uv minus the integral of v, and we have 1/3 sine of 3x v du. So we have dx to follow. So we have, once again, it is equal to uv minus integral of v du, wherein our u is x, our v is this part, so we have sine 3x all over 3 minus the integral of v, wherein our v is sine 3x all over 3, so we have sine 3x all over 3, then multiply by du, wherein our du is dx, so we have dx. Okay, so from here you can now easily see that we can now easily integrate this form sine 3x dx. Okay, so let me write this whole 2/3 here and this form here. Okay, then do not forget your bracket, because this whole term here is multiplied by 2 over 3. That's why we need to make a bracket here. Then let us continue our solution. So we have 2/3 by x sine of 3x all over 3 minus 1/3. So the integral of sine is negative cosine. So we have, rewrite it. We have negative cosine 3x and then all over 3, right? Yan, and then our plus c here. So all in all, when we simplify this, we have negative 1 over 3 x squared cosine of 3x plus 2 over 3 multiplied by x sine of 3x all over 3 minus times negative times negative, so we have positive 1/3 times 1/3 here, so we have 1 over 9, then our cosine 3x and plus c. Okay, so you can leave it this way, or you can further simplify our answer. Okay, so basically the integral of this sine, the integral of this x squared sine of 3x dx is this part. Okay, so let me continue by distributing this 2/3 in each term. Okay, so we have negative 1/3 x squared cosine 3x 2/3 times 2/3 times 1/3, we have positive 2 over 9, then x sine of 3x, then this part, so we have 2/3 times 1 over 9, we have 2 over 9 times 3, we have 27, and then our cosine 3x, then our plus c. Okay, or yeah, you can write it this way, or maybe if you want you don't want that your equation is started with negative sign, you can rearrange these 3 terms here. So say let me move first our 2 over 9 x sine 3x, then minus this part 1/3 x squared cosine 3x plus 2 over 27 cosine 3x plus c. Okay, but there's no problem if you and your answer here or your answer here or your answer here, they are just the same. Okay, so thank you.